Hello class. In our last class, we have seen the different protocols for concurrency control. Okay, and we have seen all this earlier. I'll just show you briefly what we have done. So these were the different categories of concurrency control protocols. Okay, we've seen how to use lock. Okay, and then we were discussing this two-phase locking where we have the growing phase and the shrinking phase. Okay, now growing phase is we know that we acquire the locks, all right, whatever item we have to access that is locked up. Okay, and then we have the lock point where whatever the operation we are supposed to do in the transaction, that is being done, and once we are done that, then our shrinking phase, that means releasing the lock. Okay, we release x, we release a y, like that, and then that is called the shrinking phase. Okay, this when we do is what is known as two-phase 2PL locking protocol. Okay, and then we have seen that there were problems of deadlock. Okay, so in this kind of protocol we can encounter deadlock and starvation also, if you remember. All right, so we have some different version of this basic 2PL. All right, so in that it is slightly modified, so let us see, it is made more stricter rather. Okay, so first of all we have in the category we have the conservative, and then we'll have the basic and the strict. Okay, we'll quickly see. So in conservative, what happens is that it prevents, because deadlock and starvation was the problem. Okay, so it tries to prevent deadlock by locking, very important, locking all the desired items before you even begin. You lock all the items, so you're very careful. Okay, so everything, just remember that list. So it's like the list. Okay, whatever you need, you beforehand you lock it, and once that whole list is locked, then only you start executing your transaction. That is your conservative. And then the next one is not that strict, but it is called the basic version. Okay, so in out there, what happens, transaction locks data items incrementally. That means one after another. It's not locking the whole thing. That's why it's called basic. And as we have seen, the basic is what we have seen in the definition. So it may cause deadlock because you're not locking all the items. So one locking can come in a way of another's transaction lock. Okay, so hence causing deadlock. And then we have the strict one. Okay, so it's very strict. So a more stricter version is where unlocking is performed only when a transaction terminates, mind you, terminates. Okay, and so it is very strict, and hence it is uh, it is it is found to be very helpful in avoiding the deadlock. Okay, so these are the three versions of 2PL. Right, now let us see the other one. Okay, now this is deadlock. We've seen this, and here there's a small point about deadlock, how to deal with deadlock. Okay, so deadlock dealing comes in three categories. The first thing is prevent it. Okay, transaction locks all data item it refers before it begins execution. So you are trying to prevent deadlock to happen by locking all the items. So it's just that list kind of thing, lock one, lock two, lock all the items, and then when everything is locked, then you begin. So that way you're totally preventing deadlock. In no chance, there's no chance that deadlock will happen again. Next is you allow deadlock to happen. Okay, a deadlock detection means what? You allow deadlock, and then you detect, and then you find ways to resolve that deadlock condition. Okay, you may choose one transaction, you can kill the transaction, like that. Okay, but you are allowing. In the first case you are preventing, next case you are detecting, that means allowing it to happen. And the third one is also related, quite similar to the first one, and that is avoidance. Okay, so here you don't allow, and this will lead to many variation of two-phase locking. So some avoid deadlock by not letting the, we know that cycle means deadlock, so we will not allow cycle to be formed, so that way we are avoiding. Okay, so that is the different ways to deal with deadlock. You prevent it, you detect it, and the last one is you avoid it. Okay, so that is all about 2PL. What is left is time-based protocol. Okay, now in time-based protocol, the logic is very simple. It is based on time. Okay, timestamp. Now every operation you do is of a transaction in a timestamp will be having a stamp called a timestamp. Okay, so a read you are doing, read of T1, that will have a timestamp, let's say 2, Then if it is a write of T2, that is another transaction that is happening later, so it will have 3, just like time. Okay, so like in a bank counter, if you remember, if you go and if there is no counter system, then what will happen? There will be a pool of people. Then how will you choose one? Okay, that's the problem. That concurrency control is not there. So here also they apply that logic of giving them a stamp. Okay, you get the tokens. Similarly here also every operation gets the token, and from the token we know which is the most which is the oldest and which is the youngest. Okay, so that way, priority is given and they try to avoid concurrency problem. Okay, so let us see what is happening here. So time-based concurrency control algorithm, there is this basic timestamp ordering. So what happens here is that transaction T issues a write item X operation. Okay, so first it is the conflicting operation. So there we have either we have to do write or read. Okay, now write can have problem. Let us say it's trying to access an item X, and that item will have, let's say some other transaction have done a read of X and a write of X. Now write can have problem with the read. Okay, so we will see that write to read. Now, so whenever a new transaction, so let's say this write and read is there. So we are now looking at this write and read combination. That is one combination that can be contradicting. Okay, so what happens here is that a new transaction, let's say, it comes and tries to do a write item X. Okay, so this he wants to do a write item. So first he has to check the, now write we are not considering, we are the other contradicting is read. Okay, so let us check the read. Okay, read timestamp of another transaction. So if that read, now there can be two cases. Now this is very important, listen. Read item, the read of this. Okay, this is the current one. This is the T. Okay, don't get confused. This is the T. That is the current one, the current that we are considering. And this is already that is there. Okay, this is, let's say, your TS. Okay, so T wants to do now and he is checking for TS. So because T wants to do write, he has to check for read of TS. And if he sees that the read of T, the timestamp of read is greater, okay, greater, that means let us say the timestamp of read is 4 and this is, let's say, 2. Okay, so 4 is greater than 2. 4 is greater than 2. So if that is, and similarly if it is a write can also be contradicting. Okay, that is also greater, 4 and 2. Okay, so both we are considering. I was always saying that it is read. Okay, here the condition is right because both combination is contradicting, read and write and write and write. So if this is the matter that the timestamp which is already there is greater, that means this have like in a clock. Okay, so obviously the fourth one will be the recent one. Okay, the recent one. So this was the most recent. Okay, so because it is most recent, the value is high, so it will happen late. Okay, TS will happen after T. 4 means after, 4 comes after 2. So 4 will happen after T, and similarly write also will happen after T. So this is not allowed. Okay, how can it happen? Okay, how can you write when already someone has read? Okay, it will be read. So that is why we say that a younger transaction has already read the data. Okay, someone will be reading the data, read the data. So you cannot write now because it is someone is has read the data. Okay, because the value is read or written the data. So we cannot carry on with this. Whatever T is trying to do right, he cannot do it. He has to abort, and whatever is done, he has to roll back T and reject the operation. Okay, this condition is depicting that if read or write value timestamp is greater than 2. Okay, so and if that is the case, you cannot carry on. T has to stop. If that is not the case, it's not exist, then it's not a problem. Okay, if it is 2 greater than 4, that means 2 can now carry out. Okay, it's not a problem. Oh, sorry, what did I write? Okay, so if that is coming late, then that's not a problem. Okay, if it is coming at TS is coming at 4, then that's not a problem. Okay, 2 has already happened, so that's not a problem. So you execute. You can do your write now, or if you want to do read also, write and write. And after doing that, after you have written write item, you have done write, then whatever is your timestamp, okay, that timestamp has to go to the X timestamp. Okay, if it is 4, it has to be 4 now. Okay, so that is basic timestamp ordering. You relate the time, you compare the time, and the time will allow, the timestamp ordering will allow whether you can carry on the operation or not. Okay, the next is, okay, we've seen what happens when you want to do a write item X. Similarly, the next one is issues a read item. Now again, read item, same thing. Read will be compared with write. Read is not a problem. Okay, so read will be compared to the write item of TS, and again the same thing is found. That's a write item, the value is greater than the current TS. That means what? A transaction is already written. Write means what? Greater, or has already written. He has done some changes. So how can you do read now? Okay, so you abort and roll back. So here also you abort because the write here has a higher timestamp. Okay, and that is the case, you reject the operation. And then if it is not the case, if it is less than, if it is less than, then good, then you can do a read, then execute read. And once you have done that, also you have to update the value of TSX, read TXS to the larger, to the one that you're having current now. Okay, so that is entirely based on the timestamp, and hence the name is called timestamp based concurrency control. Okay, so that is how they try to resolve concurrency control in case of basic timestamp ordering protocol. All right, so similarly another version is there which is more stricter. Again, it's the same thing. If t then delay the t. Okay, I'll not explain it much. All right, so the delay t until the transaction t prime. So it is totally based on timestamp. We'll check. Okay, and then for write also you have to check the timestamp value. For read also you have to check, and then accordingly you allow or you disallow. Okay, or you delay also. Here it is delay. So that is your basic timestamp ordering. Okay, so log-based, let us see the theory. Log-based protocols help us to manage the order, and that way we decide whichever is the younger one, we allow that between the conflicting operation, when will they execute? Okay, if it is conflicting, it is creating problem, we don't allow. And if it is saying, okay, the ordering is good, safe, then you allow. Okay, so that is how they try to manage the conflict as soon as the operation is created. Okay, so here I have an example here, T1, 10, 20, 30. Priority will be given to T1 because, you know, it came earlier. So, because based on the timestamp. And when we do this, follow this, we have schedules as serializable. We can do it according to the serial because we are following the timestamp. Definitely it will be serializable. No waiting for the transaction. Okay, so because no waiting for the transaction, that means deadlocks are eliminated. And but the problem here is, though we are getting rid of deadlock, but starvation. Okay, if you are coming late, then you may have to starve for a while. Okay, so that is the decide. So I hope it is clear. The last protocol, that is your time based protocol. Thank you, class. Okay, any problem, feel free to ask me. Bye bye.